Hello बच्चों, welcome to Shukla Maths Academy Jabalpur, and I am Professor G.P. Shukla, and today we will discuss about the binomial theorem for class 11th Maths. Because the binomial theorem is very interesting chapter, and if you will understand properly this binomial theorem, then you can easily solve any problem based on the binomial theorem. We are trying to explain the concept of binomial theorem properly in this video. So now we start. So now we have the expansion of x plus a whole is to n is equal to nc0 x is to n plus nc1 x is to n minus 1 into a and so on. Its r term is ncr x is to n minus r into a is to r and plus so on up to n plus 1 term, because the expansion of this x plus a whole is to n contains total number of terms are n plus 1. Remember that, okay? So because this is the expansion of two terms whole is to n, so it is called a binomial expansion. Binomial means two terms, right? So we are finding here expansion of two terms, so it is called binomial theorem, okay? So now see, in this expansion the powers of x are increasing, right? In the first term x is to n, and here a raised to not present, so we can write here a raised to 0, okay? Plus, and coefficient or constant term is nc0 in the first term. Second term nc1, right? And the power of x is decreasing by 1 and power of a is increasing by 1. Similarly, in the third term, the power of x is decreasing by 2, means by again 1, so it is by n minus 2, and power of a is increasing, right? So we arrived at the rth term, that is called the rth term of this binomial expansion, and its formula is given by ncr x is to n minus r into a raised to r. We can separately write this, that is r plus 1, right? Because the expansion of this binomial theorem contains total n plus 1 term. So that is called the 0 term, that is first term, that is second term, and that is the r plus 1 term. Remember that. So tr plus 1 is given by ncr into x is to n minus r into a raised to r. So dear students, you will remember this formula of r plus 1 term, and we must use this formula so many problems in binomial theorem. Okay, and now if we replace the a value of a by minus a in the first formula, so we get the expansion of x minus a whole is to n. And in this expansion is the same of the previous one, only changes is that the terms are coming alternate plus minus plus minus plus minus, right? Now see that the formula is same as previous one, only sign is changed. The terms are coming alternatively plus and minus. So first term is plus, second minus, then plus, then minus, it is minus, okay? Then plus minus. R plus 1 term is coming minus 1 raised to r, okay? Because the sign depends on the number of terms. If term is even, then the sign will come positive. If term is odd, then sign will be negative. So we will write here minus 1 is r. If r is even, then the term will be positive, and if r is odd, then term will be negative, and so on. And the last term, that is n plus 1 term, is minus 1 is to n into a raised to n. It is depends also n, it is maybe positive or negative. According to n, even or odd, it depends on the n. And now, so this is the basic fundamental concept and formula to expansion of the binomial theorem. And the general term or r plus 1 term, tr plus 1, is given by ncr into x is to n minus r into a raised to r. So now we will take some problems based on these formulas of binomial theorem. Then dear students, you will become perfect to solve any question based on the binomial theorem. And if you like my videos, my lectures, so don't forget to subscribe my YouTube channel and also press the bell icon for timely video updates and also live sessions. So now our problem number 1, expand the term 2 upon x minus x by 2 whole is to 5. So now dear student, we have given the term in the form of x minus a whole raised to n. Here n is how much? N is 5. So total number of terms in the expansion of this problem will be n plus 1. So remember that is 5 plus 1, that is 6. So total number of terms will be 6 in this expansion. And now here we know that the expansion of x minus a whole raised to n, because our given problem of the form x minus a, right? So we must use here the formula x minus a whole raised to n, that is nc0 x raised to n minus nc1 x raised to n minus 1 into a plus nc2 x raised to n minus 2 into a square and minus so on. Its r term is minus 1 raised to r, ncr into x raised to n minus r into a raised to r, and its n plus 1 term is minus 1 raised to n into a raised to n. Now taking the value capital X is 2 upon x in this expansion, and value of a is here x by 2. Take only term without sign because we are using the sign in this expansion. So now putting these values of capital X and small a in our formula, so it becomes left hand side 2 upon x minus a is x upon 2 and n is 5. So now nc0 means 5c0, x is 2 upon x, right, whole raised to n means 5 minus nc1 means 5c1, our x is 2 upon x whole raised to n minus 1 means 5 minus 1, so it becomes 4 into a. Our a is x upon 2 whole raised to r becomes 1. Here remember that the sum of terms of x and a always equal to n, that is 4 plus 1 is 5, so it is correct. Now next sign is plus, because sign are coming alternatively plus minus, then next plus 5c2 2 upon x whole raised to less than 1, so it becomes 3. Okay, and the power of a x by 2 becomes more than 1, so it becomes 2. Then next 5c3. Okay, 5c3, x is 2 upon x whole raised to n minus that is n minus 1, n minus 2, n minus 3. So 5 minus 3 is 2, and x upon 2 means a raised to r is here 3, so it is 3. Sum of and the power of x and a always equal to n, so it is 5. The next term is plus 5c4 2 upon x, so 5 minus 4 it is 1, and a is x upon 2 whole raised to r, our r is 4, and now next term is 5c5 2 upon x whole raised to here 0 and x upon 2 whole raised to 5. Now see that our expansion here end because this expansion contains total number of terms are 6. Okay, first, second, third, fourth, fifth, that is 6. Okay, when the power of capital X becomes 0, then we reached at our last term of this expansion. And now we will simplify this. So it becomes 5c0 is 1 because nc0 is 1, so 5c0 is 1, and 2 upon x whole raised to 5. So write down this 2 raised to 5 upon x raised to 5 minus 5c1 is 5 because nc1 is n, so it is 5, and 2 upon x, so write down 2 raised to 4 upon x raised to 4 into here x by 2. Okay, 5c2. We will find the value of 5c2 here. 5c2 is factorial 5 upon 5 minus 2 into factorial 2. So it becomes factorial 5 upon factorial 3 into factorial 2. So it becomes, break the factorial 5 into 4 into factorial 3 upon factorial 3 and factorial 2. It is cancelled. 5 4 is 20 and factorial 2 is 2. So it is 10. So value of 5c2 is 10 and 2 raised to 3 upon x raised to 3 and into x raised to 2 upon 2 raised to 2 as it is, plus 5c3. 5c3 we will find here. 5c3 is factorial 5 upon 5 minus 3 into factorial 3. So it becomes factorial 5, and here factorial 2 into factorial 3. So 5 into 4 into 3 into factorial 2 and factorial 2 into factorial 3, that is cancelled. So we have factorial 3 write down 6. So 2 3 is 6, 2 2 is 4 and 3 3 cancel, 5 2 is 10 also. So 5C3 is also 10 and 2 raised to 2 upon x raised to 2 into x raised to 3 upon 2 raised to 3. And now next term is 5C4. 5C4 becomes 5 because nc n minus 1 is, and that is n. So it is 5 and 2 upon x into x raised to 4 upon 2 raised to 4 means as it is. And plus 5C5 is 1. Okay, and 2 by x whole raised to 0 is 1 into x upon 2 means whole raised to 5. So x raised to 5 and 2 raised to 5. So our expansion becomes, on simplification, this 2 raised to 5, that is 32 upon x raised to 5 and minus 5 as it is into 2 raised to 4 is 16 upon x raised to 4 into 2, so 2 into x raised to 4 and plus 10 into 2 raised to 3 is 8 upon x raised to 3 and 2. So x raised to 2 will be cancelled by this 3, so we have only x in the denominator into 2 raised to 2 is 4, so it is 4x. Okay, and minus 10 into 2 raised to 2 means 4 upon x raised to 2, and here x raised to 2 will be cancelled by this x, so we get in the numerator that is x upon 2 raised to 3 is 8. And now plus, now student, remember here in this expansion the sign between the terms are coming alternatively, plus minus plus minus plus minus, remember that. So next term is 5 into 2, that is 10 upon this x will be cancelled by this x upon 2 raised to 4, so it is 16 into x and minus x raised to 5 as it is upon 2 raised to 5, that is 32. Okay, now on simplification we get this expansion of the given problem. So 32 by x raised to 5 minus 2 8 ja 16 cross it, 8 5 ja 40 upon x raised to 4 plus here 4 2 ja 8, so 10 2 ja 20 by x and minus that is 4 1 ja 4, 4 2 ja 8 and 2 5 ja 10, so 5x and cross it by 2, 2 8 ja 16 and 2 5 ja 10, so that is 5 and 5x by 8 plus 5x by 8 and last term is minus x raised to 5 by 32. So this is the required expansion of the given term 2 upon x minus x by 2 whole raised to 5. And now see that the expansion of this total number of terms are 6, that is n plus 1. Total number of terms are n plus 1, so n is 5 plus 1, that is 6. Now count the terms first, second, third, fourth, fifth and sixth. Okay, so that is our answer. So that is the concept how we can expand the given binomial term by using binomial theorem, right? And we can easily find the expansion of any two terms by using binomial theorem.